Okay, today we're going to be talking about area. Okay, first question is, what is area? Well, area is just the space inside a figure. Okay, so it's how much space is on the inside of a shape. Okay, so most of us know how to calculate area. Let's say that we have a rectangle. Okay, and this rectangle is 3 by 4. Do we know what the area of this is? Well, yeah, most of us do. Most of us know that we just do the length times the width, 3 times 4, and get 12, and the area would be 12. Okay, but my question is why? Why do we do 3 times 4? Well, this 3 means that this rectangle is 3 units tall. And this 4 means that this rectangle is 4 units wide. So if I break this rectangle up, then what this means is, see, 3 units tall and 4 units wide. Well, how many squares does that put inside my rectangle? It puts 12, because 3 rows of 4 or 4 rows of 3 give me 12 blocks. That's why a 3 by 4 rectangle has an area of 12. So the formula for a rectangle, for area of a rectangle, is just the area equals length times width. Now this is probably nothing new to most of you. Okay, so all we do is we multiply the length times the width. Okay, now it may not be new, but it's very important. Okay, the rectangle is going to be the basis for us finding the area of all the shapes we do today. So you have to understand how to find the area of a rectangle, otherwise you're not going to understand how we found the area of anything else that we do today. Alright, so our next shape is going to be a parallelogram. Okay, this is a parallelogram. Now, a parallelogram looks close to a rectangle. In fact, what I'm going to try to do is I'm going to try to make this parallelogram a rectangle. Okay, so what I'm going to do is I'm going to cut it. I'm going to cut it right down here. Okay, I'm going to cut this piece off, and I'm going to move this piece over here. And this is what that will give me. Okay, so see, I took this piece, I cut it off of this side, and I moved it over here. So now I've got this. So I didn't change the amount of area. I didn't change the amount of space. I just kind of rearranged it so it's in something that I know. Now it's a rectangle. Well, if this was the rectangle, then I could find the area just by doing length times width, right? Okay, so now all we have to do is figure out what is the length and the width. What are the equivalents for the parallelogram? Well, notice the length is all the way across the bottom, and this part was the bottom, but it was over here. So it's still just the length of the bottom. Well, we call that the base. So for a parallelogram, instead of using length, we use base, which is basically the same thing, though. It's just how long is the bottom of the rectangle? How long is the base? I mean parallelogram, excuse me. Okay, now what about this width right here? Okay, well this actually isn't part of the parallelogram, is it? This is the line that I cut. So that's this line right here. So we don't want to call this the width anymore, because somebody might think you're talking about this line. Okay, we're talking about this line, so we call it the height, because wouldn't that be the height of the parallelogram? Alright, so since we find area of a rectangle by doing length times width, then we find the area of a parallelogram by doing base times height. Okay, So basically this is the same thing though as length times width, but for a rectangle the width is the height. So we don't have to worry about whether we do, say, base times height or length times width. For a parallelogram, you have to be specific. You have to do base times height, because if you do length times width, you might use this number on accident. Okay, so the area of a parallelogram is base times height. Alright, next we're going to do a triangle. Okay, here's a triangle. Okay, now again, I'm going to make another shape that I already know how to find the area of. Well, if I had a right triangle, it'd be easy to make this into a rectangle, but I don't. So it'd be a lot easier to make this into a parallelogram. Now this time I'm not going to cut a piece off and move it. What I'm going to do is draw another triangle the exact same size right beside it. See? So this triangle and this triangle are the exact same, and now they make a parallelogram. So I have this parallelogram that I already know how to find the area of. Okay? I just do the base times the height. And that's how I would find the area of that parallelogram. But I don't need that whole area because this triangle isn't the whole parallelogram. Okay? But I still have the height and I still have the base. The only difference is I don't need this part or this half. Okay? Because the triangle is only half of a parallelogram. So then that means it's going to have half the amount of area. So the formula for a triangle is 1/2 of base times height. Okay? And that's because a triangle is half as big as a parallelogram. Okay? We should know that because we split quadrilaterals into triangles already. It's half as big. So if a triangle is half as big, you have to take half of the area. So that's the formula for the area of a triangle, 1/2 base times height. Alright, now let's see if we can solve some of these problems. Okay, we're going to try to find the area of these figures. Okay, you've got a rectangle, you've got a parallelogram, you've got a triangle, and you got one more triangle. Alright, so I've given you all the dimensions that you need and some extras that you don't need. So you need to make sure that you follow the formulas and calculate the areas for each one, and then we'll look at them together. Alright, so for the first one, when we're finding area, the first thing we have to do is figure out which shape we're looking at. Well, this is a rectangle. So a rectangle is just length times width, or again, we can think about it as base times height. So base times height. So first, I have area equals length times width. That's my length and my width. So that means I just do area equals 6 times 2. So the area of this rectangle is 12. That's it. Alright, now for this is a parallelogram next, right? So the formula for area of a parallelogram is base times height. That's the 10 and the 4. Well, what about the 5? I don't need the 5. It's not the base or the height. Okay? It's just the length of that side over there, which I don't use for area. Okay, so I have area equals 10 times 4. So the area of this parallelogram is 40. Alright, now the next shape is a triangle. That means I know that the formula is area equals 1/2 base times height. Okay, so the 15 is the base and the 10 is the height. Do I need the 12 and the 13? No, they're not the base or the height. They're just the lengths of the sides. I don't need that for area. Okay, so that gives me A equals 1/2 of 15 times 10. Well, 15 times 10 is 150, and half of that, so divide by 2, the area equals 75. All right, now this triangle is a little different. Okay, the difference here is that the height of this triangle isn't in the middle, because the top of the triangle over here is above the triangle. The top of the triangle over here is not above the triangle. Okay? So if you have a triangle like this, they're going to have to tell you how tall it is out here. Okay, but it's still a triangle, so I still use area equals 1/2 base times height. Okay? And my base is still the length of the bottom, and the height is still how tall it is. Okay? I don't need the 8 and the 10. That's just how long the sides are. Okay? So, now I have area equals 1/2 of 4 times 6. Okay, 4 times 6 is 24. Half of 24 is 12. Okay, so the area of this triangle is 12. Alright, so those are our first 3 shapes today. Rectangles, parallelograms, and triangles. Alright, so now we're going to look at our last shape, and that's a trapezoid. Now first I'll warn you, the trapezoid is the hardest formula to remember, and it's the hardest one to derive, to prove. Okay, so what we're going to do here is going to seem a little confusing. Just follow along with me, and at the end you'll have the formula. Okay? Okay, but if you're following along, the formula should make some kind of sense, a little more than it would if I just gave you the formula. Alright, so again, here's a trapezoid. One set of parallel sides, right? Alright, so just like I did with the parallelogram, I can make this into a rectangle. Okay? Well, how am I going to do that? I'm going to cut it down the side, and then I'm going to move this piece. This time I have to flip it upside down, though, and fill in this gap over here. Okay? So then I end up with this shape. Well, what shape is that? It's a rectangle. Okay? So I know I just have to do length times width to get the area of my rectangle. The problem is how exactly do you get this length and width? Because notice, last time the parallelogram was easy because when we moved it, the length of the bottom was still the same. But on this one, we actually had to flip part of the bottom up to the top to make it a rectangle. So that's what makes this one a little more difficult. Okay, so first thing we need to do is learn the parts of a trapezoid. Okay, the first part is B1. That stands for base 1. Okay, now we haven't had to number the bases yet because so far we've only had one base, or both bases have been the same size. But this time we have 2 bases, the top and the bottom, and this time they're not the same size. So the one on top is B2, or base 2. See, with a parallelogram they're the same size, so we don't have to call them different things. With a triangle there's only one of them, so we don't have to number it. Okay, but with a trapezoid there's 2 different size bases, so we have to number them B1 and B2. And then we still have the height. Okay, now again, notice, just like on the parallelogram, the sides, and just like on the triangle, the sides don't matter for area. Okay, it's the bases and the height. That's how you find area. Alright, now this is what we need to find, because wouldn't this length be the size of the length of this triangle? So if we knew that, we could just multiply this times height and be done. Okay, so that's what we're going to try to find. Okay, now notice, these 2 triangles are the same size, right? Okay, so first I'm going to subtract B1 minus B2. So I've got the whole length of B1. If I take out B2, that's the middle part. I take off the middle part. Well, that leaves me with just the outside parts. Okay, well, that's a start. But I only need to get rid of one of those outside parts. So I'm going to take half of that. So I'm going to take half of it away. And now I've got 1/2 of B1 minus B2. Okay, so that's just this part right here. Now, so all I have to do is subtract this from the length of B1, and I'll have the piece I need. Okay. Now notice, I'm going to go ahead and simplify this so that it's easier to use. Okay, I just distributed the 1/2 B1 minus 1/2 B2. Okay, so now I'm going to subtract it. So I've got B1 minus 1/2 B1 minus 1/2 B2. Okay, notice I just did B1 minus that little piece, which was this. Okay, so now I know that this, whatever this is my question mark. That's what I need. So when I subtract, B1 minus half of B1 is just half of B1. And then B1 minus negative half of B2 minus negative is plus 1/2 B2. Now I notice that I have the halves in common, so I can go ahead and take 1/2 out. So I've got 1/2 of B1 plus B2. That's what the question mark is. And didn't I just have to multiply that times the height to get the area? So that's all I have to do, is I have to do the area is 1/2 of B1 plus B2 times the height. And that's it. Now, like I said, that one's a little bit more difficult. Okay, the formula itself is more difficult, and deriving the formula is a lot more difficult. Okay, but we have the formula now, so we can use it. All we have to know is how big is the bottom, how big is the top, and how tall is the trapezoid. And we just put those three numbers in here. We add the bases together, divide by 2, and then multiply by the height. So that's all we have to do to find the area of a trapezoid. Alright, let's see if you can do it. So you're going to find the area of these two trapezoids. Okay. After you find it, then we'll look at them together. Alright, so for the first one, again, I just need to know the formula to start with. I have the area equals 1/2 B1 plus B2 times height. Okay, so my B1 is 12, B2 is 8, and my height is 4. So I've got area equals 1/2 of 12 plus 8 times 4. Okay, so that gives me 1/2 of 20 times 4. Now at this point, I can do whichever way is easier. I could do 20 times 4 and then divide by 2, or I could just do the 20 divided by 2 and then times 4. Whichever way you do it, it doesn't really matter. Okay? Here I chose to do half of 20 is 10, so 10 times 4 is 40. Okay, so the area is 40. Now, if I had done 20 times 4, I would have gotten 80, and half of 80 is 40 too, so it doesn't matter which way you did it. You still get 40 either way. Alright, the next one. Again, I start with the formula. I've got 1/2 of B1 plus B2 times the height. Okay, so B1 is the bottom, B2 is the top. And now let's think about that for a second. Does it actually matter which one I call B1 and B2? No, it doesn't. Okay, they just have to be the two parallel sides. Okay, I can't use these two as the bases. But it doesn't matter which one I call B1 and B2, because if I do 10 plus 6 or 6 plus 10, it doesn't matter. I get 16 either way. So it doesn't really matter which one you call B1 and B2. Typically, most people call B1 the bigger one. So you can do it that way, or you can do it whichever way you want. So you get 1/2 of 10 plus 16, plus 6, excuse me, times 5. So that's 1/2 of 16 times 5. Now notice this time, it would be harder to multiply 16 times 5 and then take half of that than it would to just take half of 16, because half of 16 is 8. So, and then we can all do 8 times 5 in our head. So the area is 40. Now, I will say it's just a coincidence that they ended up being the same area, but you can notice that two things don't have to be the same exact shape and size to have the same area. Now, it does mean that they have the same amount of space inside the shape. There's exactly the same amount of space inside this shape as there is inside this shape. At least if they were to scale, there would be anyway. Okay? But we find it the same way. Identify which formula to use, find the right parts, and plug in the numbers. Okay? Now, we need to talk about one thing that I've been neglecting this whole time. Okay? And that's units for area. Okay? I've just been using numbers. But really, numbers aren't a length. Okay? You have to have something like 4 feet, or 4 yards, or 4 miles, or 4 millimeters. Okay? You have to have a unit. So really, a rectangle can't just be 4 and 7. It has to be 4 feet and 7 feet, or some kind of unit. Okay? So the area is base times height, so it's really 7 feet times 4 feet. Okay? Now what that means, when something is right next to something, it means multiply, right? 7 times feet. That's mathematically what this means. Okay? So that means I'm going to put my 2 4s next to each other and my 2 feet next to each other. Okay, so I've got 7 times 4 times feet times feet. Okay, well, 7 times 4 is 28. And feet times feet is feet squared. Notice what happened to my unit. Okay, it is squared. It is feet squared, or meters squared, or inches squared. It's always units squared. Okay? So that's one thing you have to know about area. Area is always units squared. And that's because when you multiply a unit times a unit, you get a unit squared. Okay? Whether you multiply inches times inches, you get inches squared. Meters times meters, you get meters squared. So when you're writing the answer to an area problem, you better always have the units squared. Alright, now let's see if you can finish these problems. And on these, make sure you don't forget the units. Alright, so first we have a rectangle. Then we have a parallelogram. Next is a triangle. And a trapezoid. Okay, so go ahead and find the area. It's all 4 of these shapes. Alright, so the first one is a rectangle. So I'm going to write the equation down. Area equals base times height. Okay, again, base times height is the same as length times width for a rectangle. So I like to use base times height just so it's the same all the time. So it's the same formula for a rectangle as it is a parallelogram. Alright, so that's just 3 times 8. But it's 3 inches times 8 inches. So that gives me 24 inches squared. That's the area of this rectangle. Alright, next we have a parallelogram. So the area is base times height. Okay, that's the 4 meters and the 5 meters. Again, I don't need the 6 meters. It's just extra. I don't need it. Okay, so I have 4 meters times 5 meters. So I get that the area is 20 meters squared. Then I have a triangle. Triangle is area equals 1/2 base times height. So I get 1/2 of 6 feet times 2 feet. Okay, well 6 feet times 2 feet is 12 feet squared. So half of 12 feet squared is 6 feet squared. So the area of this triangle is 6 feet squared. Alright, then last one, the trapezoid, is area equals 1/2 base 1 plus base 2 times the height. Okay, so that's 1/2 of 20 yards plus 10 yards times 10 yards. So that's 1/2 of 30 yards times 10 yards. Okay. Well, half of 30 is 15. So 15 yards times 10 yards. So the area of this trapezoid is 150 yards squared. Okay, notice I followed the formulas just like we did before, but this time I also made sure to keep my units. And I always ended up with units squared because I'm dealing with area.